Hello everyone, welcome to this exercise. My name is Hizar and today we're looking at what is GIS and what it does. And we're also going to make a spatial map using some coding skills, and it would be an interesting map to make. And we want to also understand what GIS in practice looks like and its applications are. For example, how can GIS be used to solve some of the spatial problems that we have. And here is a map of cholera in London in 1954. And what this map shows in red is that people that were drinking contaminated water were transmitting this disease to a number of areas. So once you find the source of contaminated water, you could simply stop the cholera outbreak. So GIS could be very interesting when it's applied to understand spatial patterns, and its uses are well recorded in history. So GIS simply stands for Geographic Information System, and it's primarily based on a computer, and where it manages and it can store a lot of data, and it can manipulate that data to provide some meaningful information about real world. And it can also handle georeferencing data, for example. So imagine you have spatial and temporal data. So spatial simply means the area, so you could be looking at a large area over a very large boundary, or you could be looking at a very specific area, so that's what spatial means. And when you're looking at temporal resolution or temporal dimension, that means over what or how long, for example. Are you looking at days or months? And these changes can be, if you're looking at problems, for example deforestation, you could be looking at both spatial and temporal dimension. So GIS allows you to do both of those. And also you can have analysis on a large data set. So not only can you monitor these changes with GIS, you can also do something called forecasting, and you can also think about how you might respond to those problems that you have identified. So it's not just a simple tool that identifies problems, but it also allows you to make some assumptions based on the analysis. And some of the most basic data sets used in GIS are raster data, and raster is simply based on a pixels or cells. Think of it like a picture or a photograph, and it's basically using those values. So for example, each pixel will have a value that would represent a location on the ground, and that's what raster is. So with vector data, it's very simple. You can simply have a list of values. So those values can be coordinates, x and y coordinates, and those coordinates could represent longitude and latitude. So you could have a line or a point or a polygon, and I'll show you in the exercise that we do how you can how easy it is to use those points and manipulating them to put them on a map. So you might be wondering, where is GIS used in real life? It's been used for a wide variety of applications. It's been used in engineering, it's been used in hydrology to look at rivers and how, for example, there's water cycle, so you can track the movement of rivers and how is it changing flows. It's been used in health. I've got some examples to show you, but it's been used in epidemiology to track the movement of diseases. It's also been used in geography to understand forest covers, changes in land use, also in glaciology, and it's used in biology to look at animal patterns. So how are animals moving or responding to climate change? So it has a lot of uses in a wide variety of applications. And here's an example of a recent study which looked at spatial modeling of COVID incidents in the US, and it's very interesting because they used not only spatial data but also environment and socio-economic data, and combined them together to see how, for example, spatial variation in COVID incidents affect how people live, and the red spots you see on the map are related to higher incidence rate, and blue are low incidence rate, and it's a way of representing. GIS could be an interesting way of looking at these things. So before we start mapping this exercise, there's two things that I want to mention. One is that pause the video and see if you have Notepad or Sublime Text on your computer, and don't worry if you don't have it, because you can simply download them freely available online. And the second thing I want to mention is that we're not going to be making a GIS map because we don't have the data. But if you did have your data, you could simply learn some of the tutorials from Leaflet to do those, and I'll explain what Leaflet is in the next session. So pause the video and see if you have those things, and let's begin. So what we want to do now is visit this website. It's called Leaflet Library, and if you bookmark this or save this website on your computer, I'll also provide the link at the end of the video, and you can visit this website whenever you need to. And it's an open source library which provides the code for your map. And one of the similar maps that we want to create is, as you can see here, we want to create a map like this using the code down here. And since we don't have a lot of data, we can't plot any of the GIS mapping, but you could do that with Leaflet, and I'll show you how. For example, you could use some of these tutorials, and you can create maps that are custom build markers. You can use these tutorials for your mobile phone. You can also use GeoJSON data. For example, if you had some if you had some data, say for example about crime or population, you could simply plot that using GeoJSON and Leaflet Library. You can also have interactive choropleth maps, so you could show density between for example the US states, or you could use that with any other data that you have. And these examples help you get started, but the point of our exercise today is simply to get started with how we can make a map, simple map. Okay, so if you have downloaded, or if you've opened your notebook or Sublime Text on your computer, it might not look the same because we're not using the same software, so yours might look completely different. So no worries in there. It's just that you want to make sure that you have got the correct version of the code. That's all. And you can type it or you can simply copy and paste. First thing we should do is save as, because it's very important to have our file save, otherwise it might not work. And I've already saved it, but I'm just going to show you how you might want to do it again, because it's very important to have this saving setting. And you just need to type HTML, which is the extension, and it's very important to have that, because otherwise your computer would not recognize what kind of file that we're dealing with. And then you save it, and it's asking me to replace, but obviously it's the same file that I was working on already. Copy the code that I've provided with this film, or you could simply type this while I'm working on this and try and explain this code. And if you've never done coding before, do pause whenever you need to, but don't worry if you don't understand any of this, because you don't need to know everything. It's just for your understanding. And when I try to explain, you'll see that it's not that difficult. It's once you experiment with it, you might feel comfortable. So don't worry if none of this makes sense. When you think about it, you've got HTML, which is in tags, and you have these tags called head, and these heads close. And once you have these closed heads, you can always put a lot of information. For example, you can put title. I've called it GIS. You can call it the map, and this title is basically the title of the website that we are trying to create, in which there will be a map that we produce. And then you have these links. They actually come from Leaflet, and what it does is it explains where these links come from, and then tries to find that information from the leaflet, which is the library which contains the information about maps. And once you move on and you go to styles, and styles are simply based on what you want your map or the website to look like. If I want my map, which is here, if I want my map to look like maybe cover 50% of the web page, then I can change it to 50%. Or if you wanted to make it 100%, you could do that as well. You could change the paddings and margins and also width and height. Once you start to experiment with this, it's not too difficult. Moving on, the head closes here. So basically the part of the website where we're looking at, the head is what we've closed. And now we move on to body, which is the main part of the website. Anything that goes inside the script deals with JavaScript, if that makes sense. And you have a variable called map, and inside that map you also have a map. And then you have a constant which has a map center, and you can have latitude and longitude, and inside those you have these values which are representing coordinates or map coordinates that we have already talked about before. And then you have a map which sets a view, and you want this to be 16, and so that is the zoom view of where you want the map. And then you have a variable called tiles, and these tiles come from Leaflet, as I've already explained, come from an open source library. And if you save all this, you making sure that these tiles are added to the map, because once they are added to the map, then you can show them on the screen. And then you have to close the HTML because it's an HTML exercise. Once you've saved all of it, you can see that I've saved my map here. And once you click open, and you can open it with any browser that you have, you can open it with Firefox or Google Chrome. And once you see, you open it, and you can see that it's a map that you've created. And you can also see the name of the website, and you can see it here. I mean, it says on the map, and you can change it. And the reason it's only covering 50% of the screen is because I've chosen to have 50% this way and 50% this way, height and width. You can always change those parameters to add included whatever you want to do, and you can play around with this map and see what you like best. But what I want to do is maybe add some vector data in this map, because it's not very it doesn't have anything. You can't click on it, you can't do anything, but you can do a lot with this leaflet library that I've already shown you. So let's say if I've got some code here, and if I were to make a circle on a map, all I need to do is call l.circle function, and then just add a value, for example longitude and latitude coordinates, and then you can have colors. So I want the circle to look like red, and then you can have some fill color. What do you want the color that needs to be filled? And then also you can have an opacity and then radius of 500, and then you can add that to the map, and you save it, and then you try and rerun the map, and you'll see that there's a circle that's you've created, and it's not too bad. It's a good looking map. And then you can also add, if you wanted to, you can add a polygon or a building, and you could do that with these different values, and you can get those values from any of the Google apps or anything that you want to. And I think maybe you want to explore this and see how you can find values and include them yourself. And now of course you can't see the polygon because I think the values are for London and not for Manchester. So if I zoom out a little bit, maybe you go to London, and you'll see that it's appeared on the map. Maybe let's make this map a little bit big, maybe 100%. And then once you save it and then you rerun it, now you can see that you can see much better, much clearly. And you can include any information that you like on the map. So as you can see, you can add quite a lot of data, and this is vector data that you can add, and maybe think of other ways you might want to add So for example, you could add markers. So maybe try and play around with this code and see what else there is that you might discover. But also think of how you could use your own data and use some of these tutorials to understand how mapping and GIS really work. And this is the end of the video. This is the end of the exercise. So we'll move to final few slides, and then we can wrap up. So I hope you enjoyed making that map. Here's one of my studies where I was interested in looking at river vegetation and its influence on river flows. And what I did is I took images with a drone, and then I stitched them together to create a mosaic, and then I simply created a raster data set. So once you've taken your pictures, you can simply draw with your software. You can draw the plants where the plants are. Computers sometimes recognize them, and that's your vector data plotted in top of a raster data. So those plants can be manipulated, and then you can do some simple analysis to see where those plants are and how does this affect the river flow, basically. Once you've drawn your polygons, you can simply run some hotspot analysis or any other statistical analysis that you want, and then you can see the difference in vegetation. For example, red vegetation shows that these are clustered, highly significantly clustered with some confidence, and blue and yellow are showing the plants are not as much clustered, but maybe they're a little bit far away. And I mean, it can answer some of the questions about, for example, how does river flow respond to these vegetation changes, and how spatially distributed this vegetation affects the river morphology and nutrients. So it's very interesting in that sense. In summary then, GIS, we've looked at vector and raster data. We've looked at what GIS is and what it can do. For example, it can do a lot with data manipulation and large processing. We have created our own spatial map, so even though we didn't have a lot of data, we can still plot that data because it's a fundamental understanding of how maps are made. And GIS is quite powerful software. It can be used in wide variety of applications in real world to solve problems that are unresolvable otherwise. So I have shown you some of the examples, and I've shown you some of the tutorials that you could go and hopefully try and learn more. And if you did have your own data, you could simply make a map that's as simple as the one we made using vector or raster data, or you could make much more complex maps. So if you did have some data, you could go on Leaflet tutorials and learn more, or you could go and explore ArcGIS. So it's a wonderful way of looking at a world that is out there. Thank you for listening, and goodbye.